Welcome back to the Cave of Science, and today we're going to look at quantum numbers. We're just going to discuss what they are, and then on the next video, we'll actually go through and assign quantum numbers to electrons in an element. The principal quantum number, or a lowercase n, tells the energy of an electron and size of the orbital, or distance from the nucleus. This is really the shell or the level. So n is always going to be something greater than or equal to 1. And that again describes the shell or the energy level. Again, the higher the value, the farther away from the nucleus. Now, if you want to know the total number of orbitals, it's going to be n squared. So that's going to be the total number of orbitals. And we'll look at that in the next video. So that's the total number of orbitals. The next quantum number is the angular momentum number, and that is a lowercase n. Now this is the shape of an orbital, and again we're not going to look at the shapes right here, but with a particular quantum number, it divides the shells into subshells or sublevels. Now as you go through electron configuration, you'll have the s, p, d, f, g, and h. Well, L's, again, you're looking at quantum numbers, so you're going to assign a numerical value to these. And the S is going to correspond to a 0, P1, D2, and so forth. So that is going to be your second quantum number. The third quantum number is going to be the orientation in space of an orbital of a given energy and shape. And the third quantum number is M with a subscript of L. Now what this means is M sub L, you're going to start with a negative value and then go to 0, and then you're going to have positive values. And what you're really talking about here is that you're going to look at 2L plus 1. So if I have a value of 0 for L, 2 times L is going to be 0 plus 1. So then I'm going to have one magnetic quantum number. If I have a value of 2, or excuse me, let's do P. If I have a value of P, so it's going to be 2 times 1 plus 1. So if P, then I would have 3 quantum numbers. So my 3 quantum numbers, you're going to start with, so I would have a negative 1, I'd have 0, and a positive 1. If I would have 5 quantum numbers, or if I would be in the D, it'd be a negative 2, negative 1, 0, positive 1, positive 2. And so you start with the negative values, go through 0, and then go to the positive. And again, we'll look at these as we go through some examples on the next video. The very last quantum number is the spin. And this one's pretty straightforward. The spin of an electron can only spin in one of 2 directions, sometimes called up and down. And so these values are referred to as M sub S, or spin. So M sub S can only equal plus 1/2 or negative 1/2, either up or down. So when you see a quantum number, you're going to see 4 numerical values, which correspond to an electron in that particular element. Typically, all you're really concerned about when you look at quantum numbers are the valence electron, or electrons, and those are the electrons in the outermost energy level. So the next video, we'll take a look at some examples in putting these numbers together.